Businesses and IT leaders across the globe are replacing their legacy on-premises technology by moving to the cloud. Google Cloud Platform protects your data, applications, infrastructure, and so much more. Explore the benefits of moving to the Google Cloud Platform. Examine the microservices architecture and develop microservice apps. Discover the scaling velocity characteristics of infrastructure as a service, IaaS, containers as a service, CaaS, and platform as a service, PaaS. Then use cloud storage, cloud Bigtable, cloud spanner, and cloud SQL to define a key structure of high-write applications. Learn how to set session limits for Google Cloud Services and how to deploy and secure application programming interface, API services. Finally, identify and implement Google Cloud best practices. This course is one of a collection that prepares learners for the Google Professional Cloud Developer exam. In this course, I'll introduce the Google Cloud Platform and the benefits of moving to the cloud. I'll discuss microservices and how to deploy microservice applications, how to identify the scaling velocity characteristics of infrastructure as a service, containers as a service, and platform as a service, and the geographic distribution of Google Cloud Services. I'll use cloud storage, cloud Bigtable, cloud spanner, and cloud SQL to define a key structure for high-write applications. Set session lengths, deploy and secure API services, and learn about caching, graceful shutdown, and Google Cloud best practices. This course is one of a collection that prepares learners for the Google Professional Cloud Developer exam. Upon completion of this video, you will be able to describe the Google Cloud Platform. So let's dive right into the Google Cloud Platform. Google Cloud Platform allows you to virtualize physical assets such as computers, hard drives, and other virtual resources. So we don't anymore need to actually run these physical assets on premise. We have the ability to run them in the Google Cloud, and that could be in any of Google's data centers around the globe. There's regions in Asia, Australia, Europe, North America, and South America. Each region has a collection of zones, so these are isolated data centers within each region. As a result, when you deploy your applications in the Google Cloud, you can ensure high availability. So what other Google Cloud services can you take advantage of in the cloud? You can do things like AI and machine learning. Google Cloud has AI infrastructure and AI building blocks, and even Vertex AI to run your AI and machine learning programs. You can create models and then run those models. API management. So you can deploy API endpoints for your applications, even API front ends. And that will involve some API management, and that's available in Google Cloud as well. You can do compute services. So your physical servers, you can spin up hosts, a virtual machine on a shared host, or a dedicated host if you wish. You can also avail of containers using Google Kubernetes Engine and data analytics. So when you put all these together, you can really see some powerful applications and powerful workflows that you can incorporate into Google Cloud. Expanding on Google Cloud services because, it's not just 4 or 5. Google Cloud has a vast array of services. They offer databases, SQL, NoSQL, data warehousing. They have developer tools that you can use and take advantage of. It can be used for healthcare and life sciences. So it's all compliant with HIPAA rules. And you have the deep learning and machine learning capabilities to incorporate healthcare and life science applications and workflows in Google Cloud. You can run hybrids and multi-cloud environments, and you can incorporate the Internet of Things into Google Cloud. You can send any sensor data into Google Cloud, have that perform some analytics and calculations, and then send it back out to an IoT device to perform some specific actions. So there's a lot of endless opportunities in the Google Cloud. On top of all that, you have management tools. You need to be able to manage all these services, and being able to manage these services ensures that you can set the proper security. You know who's using what services, how much cost you're going to entail. Well, all that is included in these management tools. You get a full insight into your cloud environment. It can be used for media and gaming. Google Cloud Services run a lot of the popular gaming platforms that you see outside of the internet these days. Migration tools and migration services are available for when you want to move your on-premise physical resources or data into Google Cloud. You have full control of your networking capabilities. That would include NAT gateways. That would include creating your own private networks, your own subnets, your own sitter rooms, firewalls. And finally, operations. So operations and management tools really go a lot of hand in hand. With operation services, you can make sure that everyone's running the same type of infrastructure, or everyone has the proper patch management and so on. And we would be very amiss if we didn't talk about security and identity services in Google Cloud. Security of the cloud is of utmost importance. It's one of everyone's major questions when beginning a migration to the cloud or thinking about going to the cloud. So using Google Cloud Services, you have identity and access management. You can create users, groups, permissions, and roles. You have user protection services, and you have all the network security you need to undoubtedly implement a more secure cloud service than you probably have on-premise. You can take advantage of the new wave of serverless computing. Run your applications without worrying about any of the underlying structure. Of course, there's a server involved, but to you, it isn't. You don't even know that the server exists. You just focus on your core application development or your core Flux flows. And finally, storage. So you can use storage for backup and recovery. You can use storage for object storage for your applications. Again, Google Cloud gives you multiple different resources and services to tackle storage issues depending upon your use case. So touching back on the architecture again, the global architecture. Some resources can be accessed by any other resource across regions and zones. These are considered global resources. These are pre-configured disk images. These are disk snapshots. Networks are also considered a global resource. You also have regional resources. So regional resource means that it's available with only in that region. That can be static external IP addresses, for example. And then adding on to regional resources, you have zonal resources. So these resources can only be accessed by resources that are located in the same zone. Things like VM instances. So depending on how you want to run your applications, you want to make sure that if you're preparing for disaster recovery, then your global resources need to be used. And that's disk snapshots, disk images. And that's great, because if you did need to go to a different region in a time of disaster, these are available for you. And it's a simple migration. There's also the concept of projects in Google Cloud. So any cloud resource you allocate must belong to a project. A project is an organizing entity for everything you can build. It's made up of settings, permissions, and metadata that describes your applications. Each Google Cloud project must have a project name. You can provide your project name. It should be something that kind of lets you know what that project is. Chances are you have a project name in Microservices, and you can easily migrate that and type that into the project name field in Google Cloud. You need a project ID. Google Cloud will provide them as soon as you give the project name, but you can modify and provide your own. And a project number. And that's a completely given Google Cloud provided field. So as you work with Google Cloud, you'll use the things like project ID and project name in certain commands and certain API calls. Each project ID is unique across the whole GCP platform, and projects relate back to billing as well. Each project has one billing account associated with it. You can, however, use multiple projects to one billing account. And as a result, multiple projects will have all their bills sent to the same account. A project is also a namespace, so every resource in that project has to have a unique name. But you can usually reuse resource names if they're in separate projects. So projects are a major portion of Google Cloud, and it's important to understand how that affects your resources and your billing. Interacting with Google Cloud Services. So there's three ways we really interact. Starting with the Google Cloud Console. That's your GUI-based, web-based console that you can go in. You can create new projects, modify existing projects. You can start up any of the services that you can normally do. You can do in the Google Cloud Console. You also have command line interface, and this is programmatic access. Command line interfaces allow you to run everything in the G Cloud CLI. You can create VMs, you can create snapshot of disk images, whatever the case may be. You can install the Google Cloud CLI locally, or you can use the Cloud Shell, which is a browser-based CLI, and it's very convenient for working with your Google Cloud resources. You can also take advantage of client libraries as well. So client libraries allow you to create and manage your resources. They expose APIs, and they do this for two reasons. Application APIs provide access to services, and they're optimized for supported languages, Node.js and Python being two of these. The libraries are designed to run on service metaphors, so you work with services more naturally, and you don't have to write so much code. Admin APIs offer functionality for resource management. So you can use admin APIs if you want to build your own automated tools. So client libraries are really good for programmatic access when you're writing your applications. During this video, you will learn how to describe microservices and how they can be used for developing applications. Let's dive into the concepts of microservice architectures and microservice applications. So, microservices are a style for developing applications. Another key part of what is a microservice is understanding how they work and how they all integrate together. Microservice-based applications call on many internal microservices to do one thing only. From there, they work together to create a wider application. Each microservice will compose a response in return to the request, and this contrasts with the monolithic traditional applications, which have all their code in one principal executable file. It's much harder to troubleshoot a big monolithic application, as opposed to an application built upon microservices. And containers are well suited for microservice applications. They're used for modern cloud-native applications. Containers are good because you don't have to worry about any of the dependencies. You can create your image, point your microservice to that image, and then run that image in a container. And as a result, you can spin them up, spit them down at will. And it really jives with the microservice architectures. So, some use for microservice architecture, and it's not just limited to these few points, but starting with website migration. So a lot of your monolithic websites can be moved to a cloud-based and container-based microservices platform. Using media content in your applications. Maybe you have users who upload images or upload videos. And these videos need to be transformed into a different coding, or images need to be transformed into a different size, right? By using microservice architecture, you can use queues, and different microservices will perform different actions such as changing resolution, transactions, and invoices. Payment processing and ordering can be separated as independent microservices, and that really gives you some good flexibility.